Hi everyone, good evening to all of you. I'm back today with another video, and this is a video on the series of videos which I'm trying to record as free lectures for competitive exam preparation. So I'm looking at exams for like CLAT and IPMAT. So especially I'm targeting students of class 11 and class 12. So this is the first of the lectures which will be on the topic of algebra. So today I'm going to record this on linear equations. So let's get started. We're going to cover the very basic ideas of the linear equation. So which means that this is suitable for someone who is just getting started in algebra and wants to understand that what are the basics of algebra, right? And especially in this topic. So let us get started. All right. So first of all, let us understand what is the meaning of variables and what is the meaning of constants. In this topic, as you would be aware, we are going to frequently encounter a lot of these variables and constants. For example, x, y, z, these are your variables, and constants would be numbers, which are like 2, 4, 8, 10. So all of these are like constants, but x, y, z are variables. Also, sometimes variables can be in the form of, sorry, sometimes constants can be in the form of A, B, C, D, and those things. So, but you will have to differentiate that well. And for that differentiation, you will have to look at the question. So the question, language of the question will be such that you should understand that is it a variable? Variables are usually unknown things, but constants are known. For example, 2 is known to you, 4 is known to you, 8 is known to you, and 10 is also known to you. But in the same way, I can tell you that there is something called A, and this is something that is known to you. You don't have to find it out. It is not unknown. So then it will be a constant. That's the whole idea. Okay, let's see that what happens in the case of linear equations. Okay. So, well, in terms of in case of linear equations, what I do understand is you will be very comfortable with x, y, z, and then there will be some equations. Now, equations are what? In equations, usually you deal with arithmetic operations. So, for example, if I say that x plus 5 is equals to 8, this is an example of an equation. And in this equation, you will see that there is a variable x, which is not a known quantity, it's an unknown quantity. And this x plus 5, we'll call it the left hand side, whereas this 8 is the right hand side. So x plus 5 is equals to 8. And now you can tell that x is equals to 3. We will solve this sort of equation. And as you solve this equation, it is nothing but an arithmetic operation of sorts. You get the value of the unknown thing. This is a linear equation. All right. There is a general form which I will give you shortly. Let me write one more equation. I can also say that x plus 5 is equals to 8 into 2 minus some number. Again, it's very basic. So I'll first solve this is 16 minus 5. This is equals to 11. And then what happens is that this becomes same like x plus 5 is equals to 11, or it becomes x, or you can say that x is equals to 6. So that's the whole idea. Again, there was this unknown thing, and I was able to find it out. All right. So if you look at the two equations that I showed you, all of them had one unknown thing, which is x, and also had multiple constants. So and you saw that we used constants. Basically, we used it in terms of operations of addition, subtraction to get to the idea of the unknown, right? That's what I did. Now I can also generalize this as ax plus b is equals to c. For example, instead of having x plus something is equal to something, I can also have something called a. Now, this a is not the unknown, it's actually known, and we call this as a coefficient. This a is known as a coefficient. It is not unknown. So that's the thing that I told you in the beginning, if you can recall. For instance, if I write 5x plus 8 is equals to 10, what is sort of happening over here is that this x is a variable, but this 5 is, as I told you, it's a coefficient and it's a known quantity. Now I can as well solve this and get the answer by using the solve method of solving equations, which is 5x is equals to 10 minus 8, and then 5x is equals to 2, x is equals to whatever you get. But I want to show you how do we generalize. So we get ax plus b is equals to c. Now compare this is 5x plus 8. This 5x plus 8 is equals to 10, which means a is equals to 5 and x is x and b is 8 and c is 10. So this is the general form that you need to understand about linear equations. Okay. There are multiple things that will slowly come to discussion. For example, this topic is related to another topic in geometry, which is straight lines. And this topic also has more relationships in coordinate and other areas. But for now, we'll start slowly. I'm going to discuss just the basics, as I told you. So we have discussed the general format ax plus b is equals to c. Okay, wonderful. Let us now see some equations. So I'll write one questions. I actually like to write. I could have write it, like make a presentation or maybe write it from the computer, but I just like this writing myself. So anyway, little bit. I hope you mind don't you take it in the positive way. So we'll begin with one of the questions. So we have one question which is 5x plus 88 is equals to 100. How do we solve this? Let's say this is 5x is equals to 100 minus 88. What is happening over here is that I have taken the constant or the number on the right hand side. And now I have got 5x is equals to 22. Now as you can see that it has become simpler, right? I can just say 5x is equals to 22, which means I can just say that x is equal to 22 by 5. So I've gotten the answer as something 4.4. And it's more important is how I've approached this 5x. So 5x was a coefficient of x was 5. So therefore, I was able to solve for x is equal to 22 upon 5. Now notice the idea. If you have something as a coefficient, you will have to take that coefficient out of it. If you have to not take the coefficient out of it, you will not get the answer for the unknown quantity. So always ensure that you have taken the coefficient out. But first, of course, we'll have to like sort it out on the right hand side. Right hand side has so many numbers. Solve it, addition, subtraction, whatever is there is required, solve it, sort it out, and then bring the coefficient on the right hand side. All right. Let us now see. Let us now see something else, which is some other question, but on the same idea, which is linear equations. So one question I want to tell you, I want to show you is something where x is in the reciprocal, like in the denominator. It's a 5 upon x plus 95 or 90 is equals to 20. How do we approach this question? Let us see. So what is happening over here is that this variable x is actually in the denominator. Now what I want to do is that this variable x has to be on the numerator first, and not just on the numerator, but also I have to bring it all of them into one term and then remove the coefficient. So those are the two steps that I'm going to take. I'm going to do. Let us see. You have 5 by x plus 90 is equals to 20, which means 5 by x is equals to 20 minus 90. Okay, sorry. So if you solve this, unfortunately, what I say is becomes a negative number. This becomes a negative number. So in this case, I'll have to change the question. Maybe I'll do it 200. This should be better because I want to deal with the easy questions for now. Now what is 200 minus 90? I think it's going to be 110 because 200 is on the right hand side, 90 is on the left hand side, and as you bring 90 from the left hand side to the right hand side, what happens is that you get another simple, you get a term which is 110, and then you also have 5 upon x, which means 5 upon x is equals to 110. All right, now I'm going to bring x. So mind you, you will have to have one term which contains x. So for that, you'll have to do 5 is equals to 110 into x. What I've done is I've gotten this x from the denominator to the other side, to the numerator, right? Which means what? Which means I've done a method which is known as a cross multiplication method. So 5 upon x was equals to 110, which means that if I brought that x on the right hand side, I've gotten 5 is equals to 110 into x. Fine. Now, my original goal, remember, was to have one term with x. So I have achieved that goal. I do have 110 into x as one complete term, and that complete term, which is 110 into x, is equals to 5. Now let me try and solve for x. This becomes x is equals to 5 upon 110, which means that this will become 1 upon 22. This is your answer, right? So x is equals to 1 upon 1 upon 22. That is your answer. And I think this is your final answer, but this is not in an integer format. This, as you can see, is like a reciprocal format. Reciprocal, or you can say fraction, or you can say decimals, which is what which is fine actually, because originally the question also had this x in the form of a variable. So I think I'm good so far. I hope you're also on the same page. We'll see more examples basically, and more examples on this topic sort of will be on different types that you can see dealing with variables itself, but slightly more complications and then maybe word problems. Okay, so let's see one more example. What's the other example? What I can also do for solving this kind of sort of questions is that I can give not just one variable, but two variables, but then you will need two equations. So for example, if I tell you that x plus 5 is equals to 8 and x plus y is equals to 10. This is a very simple elementary question, but on variables. But then what is happening over here is that you don't have one variable, you actually have two variables, which is what you can see here. So let us solve. Let us first solve for the first variable. So for the first variable, you have x plus 5 is equals to 8. So maybe I can solve for x. X will become 8 minus 5. Now what is 8 minus 5? It is actually 3, right? 8 minus 5, if you solve, you're going to get as x is equals to 3. Now, remember, there's one more equation, which is x plus y is equals to 10. And you have this x, the value of x. You have the value of x, which you've already gotten, and the value of x that you've gotten is 3. So I'm going to put that value of x in this equation, x plus y is equals to 10. So I'm going to put 3 plus y is equals to 10, which means y will be equal to 7. So in this fashion, in this way, you've gotten the value of x, which is 3, and you've also gotten the value of y, which is 7, right? So yeah, this looks good to me. This was an example where you did not have just one variable, but you actually had two variables. We also call this a simultaneous sort of equation, and this also works well. On a similar lines, I'm going to give you one more example. So let us see x plus 2y is equals to 25. And one more example would be that x plus, I can give you a little more complicated, but at this point, I want to give it like a little easy. Maybe put some coefficient over here. 3x plus 5 is equals to 2y. The first one, remember, is x plus 2y is equal to 25. The second one is 3x plus 5 is equals to 2y. Let's solve it one by one. There is in this question, the coefficients are same, but for which term it's 2y. If you want to eliminate or you want to get answer for x, you will have to get rid of one of them. So what I'll do is I'll bring first of all the variables on the left hand side. We get 3x minus 2y. What do we get? We get 3x minus 2y is equals to 5, right? What we are sort of getting is 3x minus 2y is equals to 5. Now, if I add, let's call them the first equation, this is equation part A. Let's call this the second equation, equation part B. And if we are going to add these two equations, what will happen as a result is that 2y and minus 2y will get added. Now, if you add 2y and minus 2y, you will get 0 because these two will cancel each other out. So minus 2y, sorry, plus 2y minus 2y, this will cancel each other out. What you're going to get is as a 0, but you will also add x and 3x, for which you will get 4x, and you will also add 25 and 5, for which you will get 30. From here, you can get the value of x as 30 upon 4, which is 7.5. This is one of the variables that you have been able to, you are able to find out. Please take a moment, pause this video, and maybe try and see if we note it down. Okay, wonderful. So now what I'm going to do for you guys is that I'm going to put this value in any of the equations. And when I put the value in any of the equations, let's say in the first one, 3 into x plus 5 is 2, 1. Yeah. That will give you some answer what the remaining for the other variable, right? So for example, if I put 3 into 7 and half, right? This will become 22 and half plus 5 is equals to 2, 1. So what is 3 into 7.5? It's going to be, to solve it, will get some number for yourself. So you're going to get 22 and half plus 5 is equals to 2. Now, if you add these two terms, because you want to add and get the value finally for the y. So 22 and half plus 5, what is that going to be? If you add these two terms, you're going to get 27. Yeah, 27.5. And then if you sort of solve for this is 2y already, you don't have to solve, so you get 2y. And then you sort of get the value of y, which is 27.5. I mean, this is just a process, you don't have to exactly find the value of y. You just bring it on this side, divide, and then you get the answer for y. This is how, friends, I've gotten the value of x, and also I've gotten the value of y. So a wonderful way of solving questions where you use the idea of elimination of one variable. And in the process of elimination of one variable, you're able to get the answer for both the variables. And this is a great beginning to get, especially for solving the basic level questions, right? So yeah, thank you for listening. We'll end it up here. Well, as I told you, it's going to be a small, brief video. I enjoyed talking. I enjoyed taking this recording this small video. Thank you.